Hello everyone, it's me, the Cannabis Reviewer. I wanted to give you all an update on my new GROWSS system, version number 2, or at least Arduino version. Let's call it that. I don't know. I think I'm going to back off the version 2 and just call it the Arduino. We're going to have the Raspberry Pi version, and then we'll have the Arduino version. And they both have their uses and non-uses. Why did I go with the Arduino? Why did I move from the Raspberry Pi? Mostly because I want to use the Blynk app. And the Blynk app works much better on the Arduino because it's written in C++. And when I use the Raspberry Pi, I have to use a ported version that a guy ported from C++ over to Python. So the functionality of the Python, ported Python code isn't as good as the other C++ code. There's more functionality in the C++ code because it was originally written for this and it's being maintained. Whereas the Python code, since it was ported by a single guy, I mean, there are contributors, but there isn't as much action going on in terms of updates and new features or anything like that. So I move into this. The other thing is with this, when you pair this with a good clock, then it's very, very predictable in terms of when something is going to happen and when you want it to happen. The Raspberry Pi runs an operating system. This does not run an operating system. You use a computer or some other device to load the program onto the Arduino, and the Arduino now runs that program. The Arduino is a single task computer. That's why it's so predictable. The Raspberry Pi is a multitask computer. It's got an operating system that allows you to do many things with it. You can also install other stuff on it. With this, you write a program, you load it in, and it runs. Simple as that. You can do a lot with it, but that's all there is. So those are the two reasons why I decided to go ahead and move to the Arduino. I want to be able to take my Blynk app on this phone that I'm using and be able to turn on and off the lights and the exhaust and adjust the alarms and adjust when the fans and all that come on. And I really couldn't get that done on the Raspberry Pi. So I'm going to move to this, and hopefully the Blynk code will work so much better when I get to it, and I won't have any problems. At least I'll know I'll get better support because there are more people that use this C++ version, and it is also supported by the manufacturer. Whereas the Python version is very limited. You ask for support, people will try to help. They're good about helping, but not everyone uses it. Not a lot of people, as many people use it. So a lot of times you hear them say, why don't you help contribute? Which if I was that good at Python, I would, but I'm not. I'm just trying to get some nice engineering done and get some problems solved for myself. So that's what I've done. I'm moving over from the Raspberry Pi to the Arduino version. Well, I'll have both. The Raspberry Pi is going to be great for monitoring and simple control. I don't want to, with the Raspberry Pi, I have to actually go into the code and change the values in the code to change like the time and the time when the lights come on and when the exhaust, humidity when the exhaust comes on, and those kind of those kind of values. This will hopefully use the Blynk app. But that Raspberry Pi will be good for that application and that use, and I'll probably use it in my other box over here that I have for drawing. We'll see. I'm not gonna throw it away. I think it's still good and useful, and I may come back and clean up that code now that I'm getting a much better grasp on the C++ code. And that's the other thing. We'll show you. I'll get into this code and what I've done to it next after I talk a little bit more about what's going on. I want to talk to this is for intermediates and noobs out there, mostly noobs and beginners. When you're programming with hardware, there is a difference between computer science folks and ECE folks. An ECE guy is not only concerned about the software, but he's also concerned about the hardware that the software runs on. So those people that write those code tend to be a bit more matter of fact get the job done. So the code may not quite be as sophisticated as one would find with the CS guys and gals, because they focus only on the code and don't care as much about hardware because it's abstracted away. Whereas when you're dealing with this kind of stuff, you can't abstract this away. You got to know what pin numbers, you got to know what ports you're using, you got to know what commands that low-level commands that you need to use, and incorporate that in high-level C++ language to get it to work. So there's a lot going on with it. So noobs, when you start off with this, when you start testing, you start with one device, like I did. You start with one. They're all connected, but I started with this RTC first, got it working. Then I moved to the BME280 separately, got it working. Then I moved to the moisture sensor separately, got it working. And then then I put a second moisture sensor in right here and got it working. And once I got that one working, it was just a copy. I actually just used the same function call, I should say. So they all work, and they're all plugged in, but they were only plugged in one at a time originally, except for this. I did plug the other sensor in, the other moisture sensor in. So these are the basic components that I need. The RTC is a real-time clock module, which provides me the time and date, because the Arduino doesn't have that, because it doesn't have an operating system, and it doesn't have a built-in RTC. But that works pretty damn good. BME280, temperature, humidity, and pressure sensor, pretty good and pretty accurate. Soil moisture sensor, detects the moisture in the soil, you put it in the pot. Those are the main components. The other components that we'll also be adding will be relays, just to control the exhaust fan and light and exhaust. Those are next. Want to get this code running first, and then we can move on. To be honest, controlling those relays are not going to be that difficult, so I'm not that worried about getting it working. Noobs, beginners, when you're writing code, at least this is my workflow, and I think it works very well. You have two sides to your workflow. You have one side that's the hardware side. Let's get all the hardware working using the software that came from the manufacturers to read them out. And then on the other side, so you have two, the other side is the C++ code that you're using to do all the work. It's what I call the glue code that glues the hardware into the software. You want to separate them, because if you try to incorporate them too early, you're going to have a hell of a time trying to diagnose and debug it. If you get all your logic on this side all figured out, so you know that's basically functional, without even worrying about any of this, put in temporary values where you would read the temperatures and humidity. Just put them in as variables. Put them in there, and when you get that working, now you can start to incorporate one sensor at a time into the code, and you know that mostly that code's going to work on this side. You'll need to tweak and all of that, but for the most part, you'll know that the code's working. And you're not going to grab all this code that you've made and go plunk over and then drop this in. You're going to take just the code you need for that sensor first, get it working. Then after that, you can drop in the rest of the sensors slowly, because you've already got them working, so you know how to. And then get it working over in the IDE, and then start with the logic stuff. In my case, I'm going to be checking for high-low values and setting those. I'm going to be checking for alarms and setting flags for those. And then I'm going to be controlling hardware based on the time and date from the RTC and all of that shit. And then the last will be the Blynk incorporation. And I'm not even concerned about the Blynk for right now. It's not even a concern. Right now, I'm trying to get these to read out, and I'm trying to get high and low values, and I'm trying to get basically right now I'm just trying to get high and low values. I'm not even got to the alarm section yet, because I wanted to show my code and how it's working. So what I'm going to do now, we'll go into the IDE and I'll talk about it, and I'll talk about why I'm not using the Arduino IDE and I'm using this instead, and I'll show you why. Then I'll also show how this will compile and load and boot up into there, or upload into that, and then start running, and then I can show you data. So all that's coming up next. Prepare. This is the Cannabis Reviewer. I'll be right back. We're going to zoom in onto the screen.